compression in the body of the arch. You are able to feel it? Actually mathematically you can calculate the exact values, which you will do later, right. So this is the arch element. So coming to the arch, this is what is called a fixed arch. Why it is called a fixed arch? It is fixed here, fixed here. The relevance of that you learn later. It need not be fixed, it can be a hinged and hinged arch, okay, or a 3-hinged arch. So those things you will study later. So this is primarily a arch which a curved member transferring load primarily by compression. Yeah, next one. So this is a application of a, what you see here is what is called a arch bridge, right, arch bridge, and these are called the spandrels. So you need a straight road, the car cannot travel like this, right. So you create an arch as a structural member which transfers the load, then you have the spandrel members on both sides, then you have what is called the decking. On decking you have the road surface, and beautifully you go. There are beautiful arches in California, in Switzerland, right. Robert, if you want to see some beautiful arches, you put this in your computer. Robert, Maillart, Robert Maillart, a Swiss engineer who has built some of the most beautiful bridges in the very beautiful forests, right, the green areas of Switzerland. Next one. So next you have, when you have a series of elements which are loaded perpendicular like this, you call it a grid system, right, a grid. Next one. So this can be visualized as a grid, the loads are applied on these nodes here. Next. Now we look at the 3D frame, which is the most common structural frame used all over the world for doing buildings, right. So what are the comments here? What are these called? What are these white patches called? Foundation. And what are these things called? Beams. What are these? Columns. And what comes in here? Plates or concrete slabs. So as our friend said, this is made out of concrete. So these vertical elements and the beams can be concrete or steel, but the slab is invariably concrete. In a steel structure, you have a rolled steel support at the bottom, which is attached to the steel frame, and you have other things like shear studs and things like that. I won't go into those details, but just a conceptual idea. You have slabs. So these are the functional areas. So the architect creates the space and we engineers create the structure. So you see the structure and the architecture, you see the relationship. One is yin and the yang, right? One is the void inside, other is the vessel. You can compare it to a vessel which carries water or anything. It's as useful, the empty space is as useful as the structure itself. Next. So this is a practical example of that conceptual idea. Next one. So to summarize, we have flexible element, example is a rope, suspension bridge, stiff element, column in structure, stiff element beam in buildings, stiff element grids in floor slabs, stiff element 3D structure, frame building. Is that clear? I think this will be put on the Acado. All this will be on the Acado. So of course writing helps you to absorb it straight away, right? But you don't have to write word for word. They are still writing. Just give them 1 minute. It's not going back? Okay. It will be uploaded on the Acado. Okay. Yeah, next one. Now what is the thing next one we should go to? What's the next one? Plate. So I think some of you are looking at your watches and the food might be over in your mess. So let's hurry up. I'm also hungry, so let's all of us hurry up. Okay, 2D element. So we have a 2D element, which is this. Let's see what we can make out of a 2D element. Next one. Okay, here this is a beautiful membrane. Now this is a system with which all of us have played as young kids. What is that example? Balloon. Who said balloon? Balloon. Prof. Kalyanram, you can give us some few points extra. I have a habit of giving extra points for very good answers. What's your name? Srinath. Some few points, 5 points extra. So this is, if you take a big balloon, which you play with the children, when you blow into it, what happens? What's the force we are inducing? Which color? When you blow into it, the red. And how it is getting in balance, in equilibrium? By the blue colors. They are equal and opposite by Newton's third law. If you have another membrane by the side here, that will be in the equal and opposite. That way it's self-equilibrating, right? After a certain time you blow too much, what happens? Bursts. Why it bursts? That is, the stress induced becomes more than the strength offered by the membrane. When the stress exceeds the strength, the balloon breaks up. So this is a membrane. Now this is the same, if this membrane, if you invert it and say you magically make it stiff, then it becomes a shell. So the membrane doesn't have any, it is flexible. It can only withstand tensile pressure on its inside, and it has a membrane tension. But invert it, change the blue into opposite direction, compression, and apply the red from top, it becomes a shell. So so membrane structure, whether it's like this or this, has a very close relationship. But in civil engineering, you use both this way and also this way. Let's see examples of that. Yeah, next. So first example of a membrane is an air supported structure. These are very popular abroad as sports complexes. There are two types of air support structure. Next one. This is one where you have a single layer, a single membrane, and use a compressor and create a pressure inside. So high pressure. So you keep on pumping air so that loss is managed by the fresh input. Then this is a single walled membrane structure. Next one is a double walled. So double walled is you have two layers and the pressure is inside here, right? So it will be more stable and the loss will be less, the pressure loss will be less. These are special membranes, right? Let's see an example of this. So most sport complexes in the US, in the universities, they have this. So inside will be a big sports arena, and this will be an air supported structure, very beautiful and very nice to work with, right? And very cheap, not very expensive, right? Of course the current electricity is used for building up the, maintaining the pressure. Let's look at the next one, which gives the outside view of this. This is a beautiful outside view. This is a very strong membrane, right? Membrane. So it's a beautiful structure, right? And when you're not using it, you release the pressure, it just goes flat when you're not using it. So no energy is expended. Next one. Then we have a stiff element. This is the slab. So all the slab surfaces we work in our rooms, in our offices, in our